Hello friends, in this video we are going to study about the pin diagram of 8085 microprocessor. So let us first draw the pin diagram of 8085. As 8085 it is a 40 pin IC, so there are 40 pins in it. Starting from 1 to 40, we will start from 1, 2, 3 till 20, and 21 will start from here. So in this way we have the numbering of the pins. Now 21 will start from here. So this was the 40 pin IC. Now this name all the pins that what these pins are representing. The first and the second pin, they are X1 and X2. Then third pin, let us first draw, then we will study one by one all the pins what they are representing. So this is the pin diagram of 8085. The first and the second pin are X1 and X2. Third pin is reset out. Fourth SOD and fifth is SID. Sixth we have trap, RST 7.5, RST 6.5, RST 5.5, INTR, INTA bar, then AD0, AD1, AD2, AD3, AD4, AD5, AD6, AD7. These are the address and the data buses multiplexed with each other. Then we have BSS, A8, A9 till A15, the higher order address bus, S0, ALE, WR bar, RD bar, S1, I0 and M bar, that is input, output and memory operation, ready, reset in, clock out, HLDA, hold and VCC. So these are the 40 pins representing various signals of the 8085. Now we will study each of the pins one by one. So first the pin 1, 2 and 37. These three pins, they are related to the clock pulse of the 8085. X1 and X2, the crystal which is providing the clock frequency to the 8085. These are the two connections of the crystal, X1 and X2. And the output or the clock frequency, clock pulse, it is provided at the 37th pin. That is why it is written here clock out. From here the clock pulse will be given to the 8085. So we have pin 1, 2 and 37. So the clock frequency at which the 8085 works, it is 3 megahertz. Approximately it is 3 megahertz. So this 8085, it is specifying limits on the clock frequency. The minimum frequency is 500 kilohertz and the maximum frequency is 3.125 megahertz. Now let's see the connections of the crystal at pin 1 and 2. So the crystal which is generating this clock frequency, the crystal is connected at pin 1 and 2. This is 1 and 2 and this is our crystal. Its connections are X1 and X2. Now this internal structure of this pin 1 and 2 is like, here we have an inverter and this inverter is providing the signal to the JK flip-flop, and this flip-flop, it produces two outputs. One is phi 1 and second is phi 2. Phi 1 is representing the clock pulse and phi 2 is representing the reverse of it. Suppose here we are getting 1, then it will give us 0. And this output clock pulse, it is given to the 37th pin. So this pin is marked as clock out. Now this flip-flop, it will divide the frequency of the crystal by 2. So here we are using the crystal of frequency 6 megahertz and this JK flip-flop, it is going to divide it by 2. So we have flip-flop, divides the crystal frequency by 2. So we have the crystal frequency in the range from 1 to 6.25 megahertz. So when the flip-flop, it is dividing it into 2, so we are getting the output as 0. We are getting the output as 500 kilohertz to 3.125 megahertz. And these are the capacitors connected here, and these capacitors are of the range 10 to 20 picofarads. And the clock signal which is coming out of the pin 37, it is used to drive the peripheral chips. Peripheral means the input-output devices. So the input-output devices connected to the 8085, they are driven using this clock pulse. Now next in the pin diagram, it comes pin number 3. So pin number 3 is, next we have the pin number 3. So this pin 3, in the pin diagram, it shows the reset out. So this pin number 3 is showing the signal reset out. It is an active high signal. It means that it is active when its value is equals to 1. So when this reset out signal it is high, it indicates that the microprocessor, it has been reset. So all its conditions, all the registers, they are bring back to the position 0, and all the flag registers, they are also again reset. So all the components and the register, they are being bring back to their original conditions, initial conditions they are bring back. So when reset out is high, so when this signal is high, it indicates that the microprocessor is being reset. That is, all the registers and the flag register, program counter, instruction register, all are being reset to 0. So it has bring it to the initial conditions. Now when you first start the microprocessor, then the whole system, including the microprocessor, CPU, ALU unit and the control unit, all the chips of the 8085, they are in the reset conditions. Now while processing, if you want to again bring back the microprocessor to its initial conditions, then just press this switch or reset out signal, and then the microprocessor is again bring back to its initial conditions. So when you first start up the microprocessor, the 8085 is reset or initialized, and this reset out signal is high. And when this reset out signal it comes to low, that its value becomes 0, then the processing of the CPU starts. So if you want to start the processing of CPU, this reset out signal should be low, and when it is high, the microprocessor is in the reset condition. Now next in the pin diagram, we have the pin number 4 and 5. These are the sit and the sort signal. So let's study about pin number 4 and 5. Sit and sort. The full form of these signals are serial input data and serial output data. These two signals are used in when the microprocessor is used in the serial input-output communication. So when this signal is high, it means that the data which is available, it is an input data, and when this signal is high, it means the data available is the output data. Next we have pin number 6 to pin number 11. From pin number 6, it is trap. Then we have RST 7.5, 6.5, 5.5 and INTR, INT8. These signals from pin number 6 to 11, they are used in the interrupt process of the 8085. So for the interrupt controlling, these pins are used. Trap RST 7.5 to RST 5.5 and INT. These are the interrupts, various types of interrupts, trap and restart signals. And INTR is the interrupt request and INTA is the interrupt acknowledge signal. This INTA bar, it is a active low signal. INTR is an active high signal. These signals we are going to study when we will study about the interrupt process of 8085. So these pins are used for the interrupt control unit. 6 to 10 pins, they are the input pins for the interrupts, and pin 11 is an output signal called the interrupt acknowledge signal, which is an active low signal, and it is active when its value is equal to 0. Then we have pin number 12 to pin number 19. From pin number 12 to pin number 19, we have the address and the data bus, the lower order address bus multiplexed with the data bus. Pin number 12 to 19. Next we have pin number 20. Pin number 20 is VSS, that is ground. So when the voltage supply, the 5 volts power supply, it is connected to 8085, then this ground is connected to pin number 20 and the positive sub point is connected to pin number 40. So pin number 20 is the system ground pin. Then we have pin number 21 to pin number 28. 21 to 28 we have the higher order address bus. Starting from A8 to A15, and the lower order address bus, it was present at pin number 12 to 19, multiplexed with data bus, so it is represented as AD0 to AD7. These are the 8 bits and these are the 8 bits combinedly forming the 16 bits of the address bus. Now pin number 29, and we have pin number 33. On pin number 29 we have S0 and on pin number 33 we have S1. This S1 and S0, these are the status signals. These status signals define that what type of operation is being performed by the microprocessor. Of these S0 and S1, it can be 0, 0, 0, 1, 1, 0 and 1, 1. So when S0 and S1 they both are 0, then it is a halt state. When S0 is 0, S1 is 1, it is read, write and fetch. So the status of these signals 0, 0, 0, 1, it is defining that what type of operation microprocessor is performing, whether it is reading, writing or fetching an instruction, or it is at halt state. Okay, that is pause state. It is not performing any of the operations right now. Then we have pin number 30. Pin number 30 is ALE. ALE means address latch enable. This signal, it is an active high signal, and it is used when we want to demultiplex the address and the data bus. We have the address and data bus multiplex like AD0 to AD7. So when we want to separate it out, that we want A0 to A7 and we want D0 to D7, then this address latch enable is used. When this signal is high, it means that on this bus, the data which is available, it is the address of a memory location or an input device. So whenever this is high, it means that address is available on these lines AD0 to AD7. Then we have pin number 31, 32 and 34. Pin number 31 is write, 32 is read, and 34 is input, output and memory operation. RD bar means that the microprocessor is performing the read operation. WR bar means it is performing the write operation, and input output IO means it is an input output operation, and M bar means it is a memory operation. So the microprocessor, it will either perform the read operation of the memory or the input output, or it will perform the write operation on the memory or the input output. Input output, it is an active high signal, and M bar, WR bar and RD bar, these are the active low signals. So when this line IO and M bar, it is high, it means that the input output operation is being performed, and when it is low, it means a memory operation is being performed. Next comes the pin number 35. Pin number 35 is ready pin. Okay, so we have pin number 35, it is ready signal. This ready signal, it is an active high signal. Sometimes we have to connect the microprocessor to various types of devices, and the working of the microprocessor, it can be slow or it can be fast with respect to the other devices. Maybe the device which we have connected with the microprocessor, it is slow in its operation, or maybe it is fast in its operations. So to synchronize the working of the microprocessor with that device, we have to apply a signal. We have a signal, ready signal. So microprocessor, when it is connected to that device, it sends a signal ready. So it means that that device is ready to be connected to the microprocessor or to synchronize with that microprocessor. So whenever this signal is high, it means that the peripheral device which is connected to the microprocessor, it is ready for its operation. So when the peripheral device, it sends the ready signal, then the microprocessor, it gets an idea that the peripheral device, it is ready for its connection. Then we have reset in, pin number 36. Reset in. This is an active low signal. So when this signal is low, the microprocessor gets an idea that it has to reset the program counter, and it has to bring it to its initial conditions. So it is used to reset the program counter. Then pin number 37, we have already discussed. It is the clock out signal. Then we have pin number 38 and 39. It is the hold, acknowledge and hold signals. Pin number 38 and 39. Hold and HLDA. These two signals are used when the microprocessor 8085 it is connected to DMA, direct memory SS. When this is connected to DMA chip, then these two signals are used. This we are going to study in detail when we will study the DMA operation in 8085. Then we have pin number 40. Here it is the source, the plus 5 volts power supply. It is connected. It is the VCC point. So these are the 40 pins of the 8085 represented by the different signals. Again, we have pin number 1 and 2, the crystal is connected. Then reset out, SOD and SID for the serial input output data communication. Then we have the interrupt signals. We have the lower order address and the data bus, VSS, ground pin. Then the higher order address bus, S0 and S1, the status signals. Read, write and input output M bar, these are the read, write and the input output memory operations. ALE, address latch enable. Ready signal for the peripherals which are slow in their operation. Reset in to reset the program counter to bring the program counter to its initial conditions. Clock out is for the output clock pulse. A hold and HLDA are used for the DMA operation, and VCC is the plus 5 volts power supply connection. So in this video we studied the pin diagram of 8085 describing all the pins of the IC. So I hope this video is clear to you. Thank you.